Hello everyone, myself Devyani Suryakant Nikam. I am from 3rd year Electrical of Guru Gobind Singh Polytechnic Nasik. Today my PPT presentation topic is balancing phase current. Contents are information, balanced load, unbalanced load, comparison of balanced and unbalanced load, unbalancing phase current, their causes and their effects, then importance of phase balancing. So let's get started. First of all, we are going through the information. In general, three-phase loads are considered either balanced or unbalanced. A three-phase circuit is considered balanced if the voltages, currents, and power factors in all the three phases are identical. Conversely, when any of these parameters are not identical in the circuit, then it is classified as unbalanced circuit. The balance across the phases is a critical component to the power quality in power networks. When there is an imbalance on the phases, there is a direct loss in the power network, inducing upstream eddy currents in the transformer on the supply side and the neutral current loss on the load side. It is always important to remember that the loss and instability that occurs from imbalanced phases is always fluctuating. Each phase is loaded with the independent machines drawing power from the grid without any feedback on the process. So, the imbalance fluctuates according to the random pattern of the load energy consumption. Phase balancing describes the effort of an engineer to ensure that the electrical load on the given system be as balanced as possible on each and every phase. First, what is the balanced load? Balanced load in a three-phase system is a condition where all the three phases, or we can say lines, carry the same magnitude of current with evenly spaced phase differences. Then what is the unbalanced load? Unbalanced load makes the lines or phases to carry the different current magnitudes, and sum total of these at neutral point is not zero. Load in each phase is different and carrying its own current. The comparison between balanced load and unbalanced load. In balanced load, a balanced load is that in which all the impedances connected in the load are equal. So as the current magnitudes in the three phases is equal, the impedances are also equal in balanced load condition. Then what is the unbalanced load? Unbalanced load in which the magnitude of all the impedances in one or more phases differ from impedances of other phases. In balanced load, all the phases and line voltages will have equal magnitude. And in unbalanced load, all the phases are fixed and line current will not be equal nor will have a 120-degree phase difference. In balanced load, for balanced load, phase voltage is 1 upon root 2 of line voltage, and for unbalanced load, the phase voltage is not 1 upon root 2 of line voltage. For the unbalanced load, phase angle of impedances are equal and same type, that is inductive, capacitive or resistive. For unbalanced load, phase angles are not equal. So we can see in these images the current waveforms of balanced load and unbalanced load. In the balanced load waveform, we can see the similarities in the current magnitudes in all the three phases, but we cannot see this type of magnitude similarity in unbalanced load current waveform. We can see each and every current waveform have different magnitudes, different phase angles also. So what are the causes for this unbalancing of the phase current? First cause, a three-phase equipment such as induction motor with unbalanced in its windings. If the reactance of the three phases is not same, it will result in varying current flowing in the three phases and give out the system unbalance. Second cause, with continuous operation, motor's physical environment causes degradation of the rotor and stator windings. This degradation is usually different in different phases, affecting both the magnitude and phase angle of the current waveform. Third cause, a current leakage from any phase through bearings or motor body provides floating earth at times, causing the fluctuating current. Fourth cause, any large single phase load or a number of small loads connected to only one phase cause more current to flow from the particular phase, causing the voltage drop on that line. Fifth cause, switching of three-phase heavy loads results in current and voltage surges which cause unbalance in the system. Sixth cause, Unequal impedances in the power transmission or distribution system cause the differentiating current in three phases, etc. The effects of the unbalanced system. First, the unbalance decreases the motor efficiency by causing extra heating in the motor. Heat generated also affect the equipment life by increasing the operating temperature, which decompose the grease or oil in the bearing and direct the motor windings. This can cause the fire hazards also. Second, in induction motors connected to the unbalanced supply, the negative sequence current flows along with the positive sequence current, resulting in decreased percentage of productive current and poor motor efficiency. Any unbalance above 3% hampers the motor efficiency. Third, torque produced by the motor becomes fluctuating. These sudden changes in the torque cause the motor vibration in the gearbox or the equipment connected to it. The vibration and noise produced damages the equipment and also reduces the efficiency of the equipment. Fourth, the variable frequency or speed drives connected to the unbalanced system can trip off. VFD, that is variable frequency drive, treats high level unbalances as phase fault and can trip on the earth. Fifth, unbalance causes derating of the power cables and thus increase I2R losses in the cable. For distribution cables, derating factor represents the part of total current giving fruitful outcomes. Sixth, UPS or inverter supplies also perform with poor efficiency and inject more harmonic currents in case of the unbalances in the system. Seventh, negative phase sequences current flowing due to the unbalance can cause the faults in the motor, resulting in tripping or permanent damage of the electrical equipment, etc. Then what are the importance of the phase balancing? The phase balancing results in benefits such as loss reduction, voltage profile improvement, and system reliability enhancement, and many more. At LV feeders, the single phase loads make the unbalanced conditions and increase losses at the LV feeders. These loads are distributed along the feeder and have different and stochastic behaviors. Thank you.